Good morning, everyone. I will explain you how to use your drawing to check your numerical answers. Okay, so in my example, I use F2, that is the orange one, equal 45. So the magnitude is 45, and my angle is 30 degrees. FR, that is the yellow one. What we know with FR is this is 50. So this is the FR ax. It's 50. And the FRY is 25. Okay, so we can find the magnitude and angle. So FR equals 50 I at plus 25 J at. And F1, we are looking for F1. And the F3, what we know with F3 is that the gray one. We know that is a 3, 4, 5 triangle. Okay, 3, 4, 5 triangle. So anyway, I use all those data to solve, and I get my answers. And now I want to check my answers. So just the answers I get for F3, that is equal to minus 63.3 I at plus 47 J at, and the magnitude that's 79.2. The magnitude of FR, it's 55.9. F2 in dark orange, this is 38. And just put all the value because we found them. So 38.9 I at and minus 22.5 J at, and F1 at the end, we found F1, and this is 74.4 I at. Here we go. And this one is 45. Okay. So first, you can check your I at and J at complement. So F1, just on I at, correct. F2, this one, positive on I at, negative on J at, 38.9. You can check 38.9, that looks correct for the complement. Minus 22.5, that looks correct. Okay. F3 minus 63.3, so this is negative on I at, and 62.3 is there, and 47 is there. Looks great. You can measure the length, like all of that. You should measure it and put it at the scale. They should all be at the scale. Okay. And the FR, same thing, you can measure the total magnitude. So now that we have the drawing that is equal to what we found with a numerical value, the question is, did we find the correct numerical value? So for that, what we can do, we can add, there's 3 different ways to add the vector to check that F1. So what we want to check is that F1 plus F2 plus F3 equal FR. Okay, I will do the method one. Let's use the complement. Oh, I'm sorry, I keep use the complement value. So how you do that? You take, so the FR is, this one is FR. Okay, just so I don't make this. So what you can do is like you can take all the complement, one, and this one. So blue plus black got there, minus the 60, you go back all the way, and you should go back all the way to there. Okay, let me do it again with some colors. So I have F1 plus the complement on X on F2, that is this one. So almost 40, so I will add almost 40 there, minus, let's do green, minus the complement for F3X. So I go back about 665. So 1, 2, 3, 4, 5, 6. Here we go. So what I ended up with this on X. That should be equal to the FRY. Okay. For y, I can do the same. So I will add f1y is 0, f2y is down, this one, f3y is up. So if I remove this 25 to this one, I go up to there, and it should be equal to the fry. Here we go, that's equal. Okay, so that was the method number 1. You add all the y complements, you add all the I complement, all the y complements, and you check that they are equal to the fry complement and the I complement. Now, method number 2, we can use parallelogram method. So how do we do that? You need a ruler, and what you will do, we will do first f1 plus f2. Okay, let's do petit a, f1 plus f2. So this is f1, this is f2. I take my ruler, I draw a parallel line to the orange, going to the end of the blue vector, and I'm drawing a parallel line to the blue, going to the end to the orange vector. Let's make a parallelogram. The f1 plus f2 is that vector. Here we go. So it's a big. So make it a little bit smaller. This vector is f1 plus f2. Now to get f1 plus f2, so that gives us f1 plus f2, and we do plus f3. So f1 plus f2 plus f3. Let's go back with my ruler. So I take this direction, and I draw a parallel line going through the end of the vector f3. Here we go. And I take the direction of the gray vector, that is f3, and I draw this parallel line to the end of f1 plus f2. Here we go. And this vector in blue should be your fr. See how close we are? So this one is f1 plus f2 plus f3. And when we get that, we say, oh yeah, we got the right fr because the f1 plus f2 plus f3 add together. And that's super cool. Okay, and a third method, so you don't need to do all the methods, you do one of them. Let me clean that and do the third method. That is a little bit similar to the parallelogram method. That's the tiptoe method. So that was little b, we did plus f3. Tiptoe method. Okay, it just like the steps, how we add the vector is different. So we have f1 plus f2. So what you do is like you take the vector f1, let's make it straight. So your vector f1, you see the distance for me, like it will be 1, 2, 3, 4, 5, like about a little bit more than 6.3 centimeter. So I draw the vector f1 and I use the same length. So 1, 2, 3, 1, 2, 3, 4, 5, 6, something like this. So this is the vector f1 that I slide at the tip of f2. So we have f2 plus f1. So the toes of f1 is attached to the tip of f2. And I draw the sum of both of them. Here we go. That is my f1 plus f2. And now I will move my f1 plus f2. So I need to check the length. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9.5 centimeters for me. So I will move my ruler and draw a vector 1, 2, 3, 4, 5, 6, 7, 8, 9.5. This is the vector f1 plus f2 that I scoot, like slide at the end of the vector f3. So f3, tip of f3 tose of F1 plus F2, this is my vector FR. Again, super close. This is my vector FR that I should have found. So this is the three different methods. You do the one that you prefer. I read a lot of tiptoes method. Just if you say that, oh, if we do the tiptoe method, it worked, please show me your tiptoe method on your graph. Okay. Maybe you can do two graphs if it's too much information on it, but if you look there, that's not that many information. If you go one by one. Oh, and something super important that I have seen a lot, I have seen that's perfect. I have seen that your angle, don't forget to write your angle. I remove them, but this magnitude and directions are important. The 3, 4, 5 triangle and the magnitude. So all of this works only if you respect the scale. Okay, so you need to respect the scale, meaning that, for example, I say I think 1 centimeters 1 centimeters equal 10 Newton. You need to respect it on the x-axis and on the y-axis. It should be the same scale. That's why I have like little square there. Okay. And you need to draw your vector with the right length. So if your vector is 200 Newton, it will be 20 centimeter. This one is a bit long. It was a bit smaller. But you need to respect the scale, okay? Your F1 for all of you should be longer than the FR. All of you, if you find the correct value, your F1 was longer than the FR, the magnitude of F1 was higher than the magnitude of FR, so it should be longer on your graph. So I hope it gives you some a better idea of what I'm expecting when I say, does that make sense? Is your numerical value comparable to your drawings? I will try to emphasize a little bit more the modeling method, the fact that everything that we do in statics could be also drawn and solved by drawing. And that's super cool. Have a good day. Bye-bye.